My name is Martijn Walraven. I work for a company called Meteor, and I work on the Apollo platform, which is our effort to develop both open source and commercial tools for GraphQL. And to dive right in, I'd like to start with a bit of a history lesson. I think it helps to sort of frame the technology. The origins of a technology often help you better understand sort of its design, the reasons why it's been designed the way it has been. So the year is 2012, and some of you may remember this app. This was actually the first modern native Facebook app for iOS. The version before this was an HTML5 app. It wasn't well received. It was slow. It was buggy. And the question the Facebook developers working on this rewrite of the app asked themselves was basically, what would an ideal API for mobile apps look like? And why did they ask themselves this question? As I mentioned, the version before this was an HTML5 app. And there were many issues with writing a web-based app for mobile, especially in 2012. But it also had a lot of benefits. And the main benefit was that it sort of followed the standard web development model. Back then, it was mostly server-side rendered. It gave the developers a lot of control over their app. There was no separate API for the web app. They just wrote sort of server-side PHP code that accessed the database or like their data layer directly. So it allowed them to move quickly. There were no sort of long processes to design backend APIs. They could quickly make changes. If they needed to add data to a screen, they would just make the change themselves on the server. And they wanted to keep that development model as much as possible. But of course, with a mobile app, you have a much stricter separation between the client and the server. You're writing your mobile client, and you need to get the data from somewhere. As sort of an aside, I think it's interesting that when people inside Facebook started sort of publicly talking about GraphQL, and that was sort of 2015, it was mostly in the context of web apps, of React apps. And I think that's interesting because by then, the web development model had shifted and was much closer to the mobile development model. React components are also sort of client rendered depending on data from an API. So you could say that the question, sort of the design question for GraphQL is, what would an ideal API for apps in general look like? Partly because GraphQL has been mostly talked about in the context of web apps, React apps, that is definitely a place where it's gained a lot of popularity. So if you think about an API, you're most likely to think of something like this. This is the GitHub API. It's generally considered sort of a fairly well-designed RESTful API. And I definitely don't want to sort of show off GitHub as an example of a particularly bad API. And sort of spoiler, the version 4 of their API, which they released last year, is actually a GraphQL API. But I think an API like this will look very familiar to most developers. You have a set of endpoints, and sort of know what data will be returned for a particular endpoint. That's part of the contract. And there are a couple of downsides to that model. So think of, for instance, a situation where you want to show a screen with a list of repositories from GitHub. In this case, we're getting all the repositories for the Apollo GraphQL organization. You send a request to the server, and you get back data. What data you get back is sort of under the server's control. The server simply sends you a representation of this resource in REST terms. In this case, that means you actually get back a lot of data. These are just the repositories in the Apollo GraphQL organization. Actually, there are more now since I recorded this movie, and this lasts a full minute. So it's a lot of data. Most of the data you probably don't need on that screen. And even though it's a lot of data, it's probably not enough data to actually draw your screen, because you might want to show information that isn't contained in the data you get returned from that endpoint. For instance, you may want to show not just the repositories, but also the top 3 contributors for each repository. In sort of RESTful API, like the GitHub API, that means you don't have to make extra round trips to sort of, based on the data you get from the initial call, get the additional data, in this case, the contributors. And round trips are especially bad on mobile because you're usually on sort of high latency connections, so it really slows your app down. And I mean, these are familiar problems, I think, to most developers, especially mobile developers. And I definitely don't want to say you sort of can't solve these issues in the RESTful paradigm. People obviously solve these issues, but there are significant costs to that. For instance, you could sort of expose endpoints on the server that are specific to your app, that give you the exact data you want. But that means you're now sort of designing your backend API to satisfy the requirements of specific clients. And that leads to a real tension, because satisfying requirements of specific clients means a lot of extra work on the backend, not just to create it, but also to maintain it. There's a communication barrier. You might be blocked as a client developer on the backend team, if there is such a team, actually delivering on those endpoints. And from the perspective of the backend team, it's usually not the kind of work they really want to take on. So you get into these like tensions that often sort of manifest themselves as tensions between groups. You have your client team, your backend team, and you get into these discussions on sort of what endpoints you need and whether you can get by with the endpoints they've already written. So the sort of really nice question I think the Facebook team asked themselves is, why would we let the server decide what data to return in the first place? We're developing our clients. Our client knows what data it needs. Why would we hard code on the server what data gets returned for a specific call? And the basic model of GraphQL is to let clients specify exactly the data they need, but against sort of the capabilities exposed by the server. And capabilities in GraphQL get exposed in a sort of very principled way. It's actually a sort of tightly integrated system. And I think the best way to show this is to show you a tool called GraphQL. This is an open source tool developed by a developer inside Facebook, and it really shows sort of the power of GraphQL. So on the left, you see a GraphQL query, and on the right, you see the result of this query. And as you can see, there is a very close correspondence, or the shape of the query is similar to the shape of the response. And if I, for instance, don't just want the title, but I also want the number of votes, I simply add it, and I get the number of votes. So it's, for a client developer, it's just a very natural way of describing what data they want, and also how they want it returned. But it's a fully sort of recursive system. So some of the fields I can ask for instance, here I can ask for the author of a blog post, and those have fields themselves. So in this case, for instance, I want the first name of each author. For some reason in my app, I'm not actually showing the last name, but maybe in the next version, I do want to show the last name. Well, I simply change the query and I get the data I want. And it's actually a pretty sort of simple model. It's easy to understand, but it relies on some pretty sophisticated machinery. And sort of what makes this possible is the idea of a schema. So the server exposes types, and types sort of describe the available data. In this case, we have a type post, and posts have 4 fields: an ID, a title, an author, and the number of votes. And a query then selects sort of a set of fields from a certain type. That's the simple version. So the clients specify their data needs against a certain schema. And of course, most schemas have more than one type. So you end up with relationships between those types. So a post has an author has posts. And the schema in this way is sort of like a contract between the client and the server. And it's not just a technical contract, it's actually also a social contract between the sort of client-side team and the backend team. It really means that sort of the backend team can focus at what they're best at, efficiently exposing data from backend systems, describing it in a format that makes sense to the different front-end teams, and the front-end teams can focus on describing the specific data needs of their app, or of the specific components or screens in their app. And even though I started out with sort of the performance benefits of GraphQL, so avoiding overfetching, avoiding extra round trips, I think what makes GraphQL especially interesting is that it's really been designed for that kind of developer experience right from the start. So that's sort of the what the team at Facebook in 2012, the team that sort of rewrote their app, started out with. They were a front-end team. They were a mobile team. They were really thinking about sort of the developer experience of a mobile developer, not necessarily of the back-end developer. It's really about a system that is natural for front-end developers to work with. So GraphQL is a sort of quite sophisticated system. It has really sort of specific types and type constructs. Some of these will be familiar to Swift developers especially. So there's the notion of fields being non-null. There are enums, there are interfaces, there are unions. Let me show you just a few extra examples of the kind of things you can do. So this is a different schema. This is the Star Wars schema. This is often used as sort of a demo schema in the GraphQL community. In this case, we have a field called hero, and we want the name of that hero. What we get back is R2D2. So hero, like all fields in GraphQL, can take arguments. So you can define fields on types that actually take arguments. In this case, you can ask for the hero of a specific episode. So for instance, if I ask for the hero of The Empire Strikes Back, I get Luke Skywalker. I can also ask for values like appears in. That gives you a list of enum values. I can, of course, selectively get data from subfields following relationships. And what is especially nice about this is that the return type of both hero and friends is actually an interface. It's an interface called character. And characters in this schema can be either humans or droids. And GraphQL includes mechanisms to sort of selectively ask for extra information based on the runtime type of a specific object. So in this case, if the specific friend in that list is a droid, we ask for the primary function. Only droids have a primary function in this schema. Likewise, on humans, for some reason, I can ask for the height. So Han Solo and Leia have a height. Height is also an example, again, of a field that takes an argument. So in this case, it takes a unit. I can ask for height in meters, that's the default, but I can also change it to feet. Now I get back the height in feet. So you can start sort of seeing how a well-designed schema allows client developers to make decisions about sort of the way data is displayed, or what specific data they want returned, things like orderings or filters, but in a way that resembles sort of function calling in programming languages. It's a very generic mechanism. One other construct I should show you is that of a fragment. So the idea is that these queries often get built up out of smaller parts, and that ties in well with sort of component-based UIs. If individual components on your screen specify their own data needs, you often want to sort of return all that data for a screen in one query. And the way this works in GraphQL is you define a fragment, and then within your fragment, you specify your data needs. And I mean, in this case, the result is exactly the same. But you can reuse this fragment. You can, for instance, use that same fragment for the main character. So now you get the height of Luke Skywalker as well at the top. You can also combine fields that specify directly and in fragments, and they automatically get deduplicated. So even though both like friends directly and character details specify name, in the result I only get name once. So even if sort of certain data is used by multiple components, when you put those components together on a screen and you extract their fragments and build up a query, the data you get returned doesn't contain sort of duplicates. There's one more thing I should show you, and that's mutations. So far we've seen queries. Queries are a way of getting data. Mutations, interestingly, are also a way of getting data, but in addition, they also change state on the server. So in this case, we have a mutation called upvote post. This is the blog post schema again. And whenever I execute this mutation, the number of votes gets incremented. And mutations are very similar to queries in GraphQL because often, as a result of a state change, you also want change data back. But state changes on the server can make changes to a lot of data. And some of this data may not actually be something that you're showing in your app or that is relevant to your app. So mutations, like queries, allow you to select the data you want returned. All right. So if you want to know more about GraphQL, the syntax of GraphQL, there's a really nice website, graphql.org. All the query examples here are actually fully functioning graphical instances, so you can make changes in the documentation to the query and see the results updated automatically. That's a really nice way of experimenting with the language. And there's a lot more that I, of course, didn't talk about, but it's still a pretty sort of simple language. So I'll be talking mostly about the client here, but you obviously may ask yourself sort of, this whole GraphQL thing sounds nice, but how do I actually get a GraphQL API working? And what's important there is to understand that GraphQL is not sort of a database query language. It's not a language like SQL. It's not a generic language that gives you the ability to do joins or to perform arbitrary filters or orderings. It's a language that has been specifically designed to expose sort of application level data on top of any data source. And the mechanism to do that is actually relies on only one major notion, and that's that of a function. So every field in your schema, so again, the schema is what you define on the server. Every field in your schema is actually connected to a function called a resolver function, and that function is just an arbitrary function in the language of your choice. There are server implementations for various languages, and they can perform arbitrary computations. So they can access a database, but they can also call into a REST API, perform computations or data transformations. They take arguments, which they can then use to sort of change their output in any way. And what happens on the server when a GraphQL query is returned is the GraphQL execution engine on the server is responsible for parsing your query and then sort of calling these resolver functions one by one. So on the left is the query, on the right is the schema. Whenever you encounter, for instance, name, so either at the top or within friends, that is actually the name resolver function that gets called. And in this way, you don't actually have to think about the ordering of execution. As a server developer, you merely sort of define these functions in a very generic way, and the server is responsible for actually putting together the data. So like I said, GraphQL can connect to arbitrary backends. Often it's actually used to connect to multiple backends. So a single GraphQL schema can be a really nice sort of facade or gateway to different backend systems. We've sort of worked with companies that have like 40 different microservices that their apps actually have to connect to. And they've been experimenting with building sort of API gateways by hand. But GraphQL is an especially powerful technology there. And it means that as a client developer, you don't actually have to know where data comes from. You don't have to actually call into those different APIs. You just have a very clear description of what data is available to you. So, like I said, there are implementations for, I think, most major programming languages. The reference implementation is in JavaScript, so it runs on Node. There's a really great Scala implementation, a Ruby implementation, a Python implementation, Elixir implementation, Java. You'll find implementations and tools for all these languages. But let's talk about the client. So, as I showed in graphical, the basic idea is pretty simple. You have a query and you get back a result. And actually, that's all that's required to use a GraphQL API. It's not more complicated than a normal sort of HTTP RESTful API. You could use like a simple tool like curl or like a basic HTTP fetching mechanism in a programming language to execute a query. In most cases, that means you sort of send the query as a post body and you get back a result as JSON. But you would miss out on quite a few sort of really nice features of GraphQL, which isn't to say that you should always sort of use a more sophisticated client, because there are definitely cases where just calling HTTP, calling the HTTP endpoint directly is all you need. But if you want to use it as the basis for the data fetching in your app, there are two really nice features, I think, of Apollo iOS, and that's a project I've been working on, and that is strong typing and caching. So what do we mean by that? I think we all recognize this problem. Like you get back JSON data and it's untyped data. You get back like dictionaries and arrays, and you have to decide what to do with it. So parsing that manually at the point of use is not a very maintainable solution. It leads to ugly code that is really hard to maintain. So in most cases, you sort of want to translate the data you get back into types in the programming language. In the case of Swift, it often makes sense to use structs for that. So instead of your untyped dictionaries, you want to get back post instances. And writing this by hand is a lot of work. So people have been experimenting with code generation approaches, but it still means that you actually have to define these structs and then maybe like generate the parsing code from them. In the case of GraphQL, we already have a very precise description of those types in the form of a schema. So we can just use these types to generate result types in Swift and use those in the client. And that gives you something like this. So you have, again, the posts and the authors, and you just generate structs. So there are a couple of issues with this. I mean, it works. It's better than writing it all by hand, but you lose some of the benefits of GraphQL. One thing you might notice here is that all fields in the structs are now optional, even though in the schema, some information, like for instance the title of a post, is actually marked non-optional. GraphQL has the opposite convention from Swift, so an exclamation mark actually means that something is non-nullable. But in the struct, created struct, title is now optional. The reason for that is that even though when you ask for a title, you always get back a title, you may not always ask for a title. So whether you get a title depends on the specific query you execute. So it actually makes more sense to generate query-specific types. And this means that instead of relying directly on the schema, you take a query and you use that to generate the structs. So now we're no longer talking about sort of a global post or a global author struct. These are post and author within a specific query. They're actually in the generated code sort of nested within the generated query class. And that means that you now get type safety. You cannot actually access fields that you do not ask for because they're not defined on the structs. And when a field has been defined as non-null, like title, you can be sure that whenever you get an instance of post, it actually has a title. You don't have to perform that check yourself or deal with like the error conditions at the point of use. A refinement of that is to also generate structs for fragments, and I'll show you a practical example of that in a minute. So as I mentioned, this gives you sort of static type safety all the way from the server to the UI. And let me show you an example of that. So this is a very simple app. It's actually just a list of posts with the ability to upvote posts. And if you look at the code here, this is a table view controller. The table view controller has a list of posts, and that is an array. And this is the sort of query-specific post type that I talked about. So this, what you see here, the all post query type, is generated based on the information here. So we have an all posts query with posts, and that is the type you see here. In this load data method, we simply call watch on an Apollo client, giving it the query. The query is a class. We're constructing an instance of it. The reason for that is that queries can take arguments, variables. And then what we get back here is a typed typed result. So here you see it has posts defined. And then we use that to reload the table view. If you look at sort of the contents of the table view, those are defined by a table view cell. So a component that may be reused in different table views, for instance. So we don't necessarily want this table view to know what data is required for that cell. If you make a change to the cell, it would be nice if the change in data requirements would be reflected automatically in all table views that use that cell. And as I mentioned, the mechanism for that in GraphQL is a fragment. So here we specify the post details fragment, and that gets translated to a post details fragment on the post type. We use that in this case to configure the table view cell, but the code here, the table view code, the table view controller doesn't actually have to know what data is contained in post details. That is something, of course, that the table view cell has to deal with. So here we have a definition of post details. This is the kind of data we need to configure our table view cell. It takes post details and it simply uses that to configure the views. What's nice is that removing data from my query definition and recompiling now actually leads to a compile time error. So I have, this is what I mean by static type safety. When I use the title in my UI component, I have to make sure that that data is actually requested from the server. And this is something you would never get with a REST API. There could be arbitrary changes on the server. A field you are depending on suddenly is no longer returned, and it's really hard to keep track of what fields your UI components actually use. It also works the other way around. So if I try to request data that the server isn't actually prepared to give me, I get what is called a validation error. So this is again done based on the schema, on the type system that the server defines. You can, of course, define helper methods or extensions on these generated types, and you often use that to sort of format information for display. Like in this case, I want a byline for the author, or I want here the full name based on the first name and the last name. So I've been looking at this, at the generated code, as sort of similar to view models. And there's, again, there are many possible sort of iOS app architectures and ways of looking at these different roles. I think you can get away with using the generated code and extension methods to satisfy how you would use view models, because it's really sort of a tight coupling between your UI components and the data they need. Then there's one other feature I should show you. This is the upvote action that gets called when you press the upvote button. The way that works is it actually performs the mutation. The mutation takes what is known as a variable, post ID in this case, and it uses that to upvote a specific post. So that's what we pass in here. But note that we're not actually updating the UI here. This is, I think, a really nice benefit of using a caching client like Apollo iOS. You don't want to update your UI from data modification methods directly. You get a much cleaner architecture if there's sort of a one-way data flow from a store, something that sort of has the canonical representation of your data, and your UI components. In this case, we have this configure with post details method. That's where we actually define the connection between the data and the UI component. And what happens when we perform this mutation is that the mutation returns the new number of votes with an ID that is used by Apollo iOS to update its cached representation of that data, and that then automatically, because we've defined a query watcher here, sort of reruns the callback that receives a new result here. So we here receive a new result with that updated data and use that to update the UI again. So that's an example of how GraphQL can actually inform your architecture. And there's much more we could do here, thinking about possible sort of reactive mechanisms. But this is a very simple mechanism that shows the possibilities. So I've already mentioned some things about the architecture. Some other things I want to mention is the models you get are value types, they're structs. So you get the benefits of using value types. They're thread safe. You can be sure that there are no sort of, there's no action at a distance. There are no modifications made to the data without you knowing about it. If you get a result, you know that the data is all there. And for those of you who've worked with core data, because you can perform sort of arbitrary navigation in core data, you always have to be prepared that data is not there, that it's a fault, as it's called, which means that it has to be loaded from the database, may block your main thread, may result in errors that you have to handle. And in the case of these value types, when you get data, you can be sure that it's all there, and not just at top level, but sort of the whole tree of values. Then there's the normalized caching I mentioned for data consistency and these kind of reactive UI updates. You can specify a cache policy when you load data from the cache, when you execute a query. In some cases, you do want to show the currently cached version if it's there and you don't want to go out to the network. In some cases, you always want to go out to the network. You may want to first show the cache data and then an updated version if there have been changes. I think I'm running out of time, but normalized caching is sort of what makes this possible. Instead of keeping query results in sort of a response-based cache, it breaks up objects into separate individual chunks, and those can then be reused in the different queries. So if we get back a changed number of votes, for instance, we make a change in one place in the one representation for that post. That means the next time we read any query that references that same post from the cache, we get that updated value. I mentioned sort of the one-way data updates. There are ways of making manual but still type-safe modifications to the store if you get data from an external service, for instance. And there's also an Apollo Android for those of you who either work on Android or have other teams that work on Android. And then maybe the last couple of minutes, say something to summarize on sort of what I think are the main reasons for using GraphQL. I think the number one reason is probably that it really empowers app developers, unblocks them. You're no longer dependent on a backend team for sort of every change to your UI. But it's also nice for backend developers because they don't have to deal with arbitrary changes for new versions of your app or new screens in your app. They can really focus on exposing a clean schema that is usable by all clients and keeping that performant and well maintained instead of catering to individual clients. GraphQL also has the promise of sort of continuous evolution of a schema. It's not very common in GraphQL to version endpoints. It does happen, and there are valid reasons for doing it. But the idea is that you can get away with backwards compatible changes in most cases because you simply add new fields, and the old field will still be available for old clients. You're not returning that old data to new clients, and you can, over time, sort of track field usage and then only remove fields when no clients in the wild are actually using it anymore. Facebook is an extreme example of this. They actually haven't made any backwards incompatible changes to their schema since 2012, and they claim that their original app still runs against the same endpoint. And for an app that's that popular, the number of people that are still on older versions is very large. You can actually use automated tools to track whether changes you make to the schema are backwards compatible, whether you're breaking existing clients. Yeah, Facebook is one of the has sort of one of the endpoints that I think is used by the most number of people. So I think this is one number: 300 billion requests per day, over 300 billion, and it's an open source specification. They recently clarified some issues with patents, and they now use for the specification a well understood license, and for their reference implementation a normal MIT license. GitHub, as I mentioned, was one of the first public APIs last year, but there are a number of other companies who've also exposed public APIs now. We actually organized a GraphQL conference last year, which was completely sold out. Like over 400 people showed up, including people from these companies, sort of well-known companies. And in 2 weeks, we're organizing the next version of this, a 2-day event with probably around 700 people. So it's really turning into something, and I'm pretty excited about the technology and about the use on mobile specifically, because I think it hasn't received as much attention as it should. It's still relatively unknown among native mobile developers, and I would really like to see that change. So if you're interested in using GraphQL or contributing to Apollo iOS or any of the other tools, please get in touch. We have our own website, our GitHub. We have a Slack that you may be interested in. It's very active. We also have an iOS channel. Yeah, I'm not sure if I actually have time for questions.
Yes,
but
we have.
Okay.
After all, yes.
Yeah, my question. How do you do pagination for queries?
That's a good question.
Yes, and the question was how to do pagination for queries.
Oh.
Just for the video recording's sake.
That's actually something I sort of skipped over for time. But the GitHub API is a good example of that. Let's see if my mobile connection works. Yes. So there are various ways of doing pagination. Sort of one of the more complicated ones is based on the notion of a connection. Let me quickly show you what that looks like. For instance, let's see, I want issues. I can then ask for the first 3 issues. And what I get back are not sort of issues directly, but I get back what are known as edges. So this is the actual data, but within each edge, I also have a cursor. And now, for instance, I can ask for, let's see if I get the ordering right. If I now want the next 3 items, I can do something like after. That gets me the sort of next 3 items. And this is just one example of a possible pagination pattern. None of this is built into GraphQL. Like arguments like first or after are arbitrary arguments, and it's up to the GraphQL server to implement these, and it's up to clients to actually use them. And this is, I would say, you can overdo this. So some people sort of use these complicated pagination connections for, I don't know, the number of reactions or like very simple things that would you probably wouldn't have more than a couple of items in that list. And it doesn't make sense to use full pagination abstraction there, but it's there if you need it. And you can also use simpler mechanisms like a basic limit offset. It also depends on your backend systems, how well they support pagination and what mechanisms they support. That's a good question. What I showed here. Oh, I'm sorry. The question was, what was the tool that I showed to check schema compatibility? What I showed was a screenshot from an internal Facebook tool, and we, like at Meteor, as part of the Apollo platform, we work on commercial tools for things like schema management. So currently we have like a performance monitoring tool. We work on caching, quotas, other forms of demand control, and this would be part of that. Yeah.
How would you store images or similar type of big data?
In most cases, you would really want to keep that out of your GraphQL API. I think for the same reason you would want to keep them out of your REST API. I think the best practice in a lot of systems is not to return data sort of in bend with your REST request, but return URLs. And like other systems are much more efficient in sort of satisfying these requests. You could link to S3 directly or like any type of CDN you would want to use. Yeah. Yeah, I mean, this is, again, an example of an area where there are sort of different best practices. So some people, in that case, would return a URL with like some type of key that you can use to then perform the upload. And again, it's very similar to what people are doing in REST. I wouldn't sort of do that in Bend either, but some people do experiment with that as well. Like they use attachments to actually attach the data directly, and that may be a valid approach. Yep. Yeah, I mean, avoiding. Oh, I'm sorry. the question was, I mentioned that versioning of GraphQL APIs isn't often needed, and the question was, in what cases is it needed? So I would say careful schema design is really difficult. So there are definitely situations where you've decomposed your data in a certain way, you've defined types that may no longer make sense, or you've defined fields that you would really like to reuse for a different purpose. The situations are less common with GraphQL. Like it's easier to make changes in a backwards compatible way than it would be with REST. But like if you want to make drastic changes, I don't think, and you don't have sort of 5-year-old apps still connecting to that same endpoint, you may just want to make those drastic changes. Even in those cases, I think you could, by tracking field usage, by sort of knowing what clients still connect to your endpoint, you can gradually deprecate fields or types. And even then, I think it would be nicer to avoid sort of completely duplicating your API and maintaining separate versions. But if you really need both drastic changes and old clients still connecting, then similar to REST, you may still want sort of a V1, V2. But I think the situations are, I think it's less common.
Okay, yes, let's take another question and probably wrap up.
Does GraphQL support aliases? Like if the client wants a different format than what the API is actually sending, like renaming a title to something else?
Yes, definitely. So you can do that. And the main use case for that is actually when you want to return the same field twice, but with different arguments. So for instance, here we could have height in feet, but we may also want in the same call the height in meters. So now we have both. Yeah, it's magic.
Okay.
All right,
Thank you.
well,
Thank you very much.
yeah.
Guys.